This is one of the maps that we can get from NOAA, which is a National Hurricane Center map that shows the landfall or the hurricane strikes between 1950 and 2011. As you see from that map, the map on the southern part of the hurricane states and the southern part of the nation is very busy, like in the Gulf of Mexico and also in Florida, North Carolina, South Carolina. When you move to the Northeast, we only have 7 to 8 events in the last 62 years. Most important ones related to New York and New Jersey area are Hurricane Gloria back in 1965, Hurricane Carol in 1954. Long Island Express is not there in that map because we're just looking at storms between 1950 and 2011. Let's have a close look at some of these storms. The map here on the lower left-hand side, I hope I'm not blocking your view though. Okay, I can stand from here. The map on the lower left-hand side shows the hurricane tracks between 1900 and 1950. As you see from that map, most of the storms are actually zipping through south to north, making landfall in the Long Island and also in other parts of other states. Look at the map on the right-hand side shows the hurricane tracks between 1950 and 1975, just for 25 years. Once again, we have a number of storms that are moving in the direction of south to north as a straight line type of the track sets. If you look at 1975 to 2000, we have 4 storms that made landfall in the Northeast. The most important one is Hurricane Gloria, which is Cat 3, made landfall in the Long Island back in 1938. As of today, the loss estimate for that event in today's dollar value could be close to $2.5 billion. Hurricane Agnes, which is Cat 1, made landfall in 1972. Can cause almost 19 billion of cat losses on today's exposures. The map on the right-hand side actually shows the events from 2000 to 2012. We had only 2 events. One is Hurricane Sandy, made landfall in New Jersey coast, and also Hurricane Irene. One important thing I want you to observe here is Hurricane Sandy track is totally different from what we saw in the last 120 years or so. Because Hurricane Sandy here, it actually made landfall perpendicular to the coast. If you look at the historical tracks, we never had a storm similar to Hurricane Sandy. So that's the one important thing about Hurricane Sandy. It's unique. The other thing is, which I forgot to mention in my previous slides is, this is the second storm in the last 100 years to make a direct landfall in New Jersey coast. The last time the hurricane made landfall on the New Jersey coast was back in 1903. So this is the second storm in the last 110 years. I think this is the one that made direct landfall in New Jersey back in 1903. So another important point here is, in general, hurricanes, they tend to have intense wind speeds on the right-hand side of the track, and then less intense winds, relatively less wind speeds on the left-hand side of the track. As you see, many of the storms that are passing from south to north, the intense wind speeds are always on the right-hand side of the track, affecting the ocean, not really affecting the property sitting on land. But when it comes to Hurricane Sandy, it's making landfall at a perpendicular direction to the New Jersey coast. The property sitting on the northern part of the track are experiencing relatively strong winds compared to the property sitting on the southern part of the track. However, overall, the wind speeds from Hurricane Sandy are less intense compared to 1938 storm, if you want to compare that way. Let's look at 2 storms, Hurricane Sandy versus 1938 storm. The red line indicates 1938 New England Express storm, which is a Category 3. And then the blue line indicates Hurricane Sandy track that made landfall back in October 2012. As you see here, Hurricane 1938 storm, the stronger wind speeds on the right-hand side of the track, affecting Rhode Island, Providence, and then also Connecticut area. For that reason, all the water from the ocean is pushed onto Providence area, impacting Providence area with significant storm surge amounts. In addition to that, winds are in the order of 120 miles per hour from this storm, affecting all the properties sitting in Rhode Island and then also Connecticut. When it comes to left-hand side of the storm, where the majority of the exposure for New York and New Jersey areas are sitting, the wind speeds from 1938 even are less significant. However, if you look at Hurricane Sandy, by virtue of making landfall at perpendicular direction to the coast, the property in New Jersey and New York area are significantly affected by this storm. In addition to that, having intense wind speeds on the right-hand side of the track, water was able to push it through upper and lower bays of Manhattan. That's why we have significant storm surge in the Manhattan region and then also in the Long Island area from Hurricane Sandy. One of the interesting questions that was asked by one of my colleagues based in Minneapolis is, what if Hurricane Sandy gets intensity like 1938 storm? Yes, it can result into a different scenario. Why? Right now, if you look at Hurricane Sandy damage estimates or the damage, we see significant of damage is coming from storm surge or the flood component of the hurricane, because the wind speeds were in the order of 80 miles per hour from Sandy. So wind loss from the wind component to the property is less significant compared to the loss from storm surge component. But if we assume 1938 storm strength to Sandy means 120 miles per hour wind speeds on the right-hand side of the track, we could see significant amount of loss coming from wind component of the hurricane, in addition to storm surge. So somehow, I can say we are fortunate to not to have that kind of wind speed from Hurricane Sandy. If we look at meteorological characteristics of these two events in terms of central pressure usually defines the strength of the storm, right? So Sandy has a central pressure 941 millibars. Lower the central pressure is the stronger the hurricane. Okay? And the 1938 storm has a central pressure 945 MB, which is millibars. So Sandy should be a stronger hurricane or a stronger event compared to 1938 storm. But because it interacted with the other storm that's coming from the north, actually Hurricane Sandy lost all its structure before making the landfall, even though it holds a lower central pressure compared to 1938 storm. Another important thing here to observe is Sandy was moving at a slower pace, which is 23 miles per hour onto the land, where Long Island Express, as the name suggests, is moving very fast, 40 miles per hour. So Sandy was pushing all the water from the ocean onto the land slowly. It's not giving any opportunity for the water to recede. Where for the Long Island Express, one big push from the storm because it's moving very fast compared to the Sandy. I mean, those are the unique things about Hurricane Sandy. I mean, if you look at the history, we might have only one event or maybe two events that are similar to Sandy that are making landfall at a perpendicular direction to the coast. Okay, that will lead into why storm surge from Sandy is significant. In addition to other things that I discussed you before, I think the storm surge actually occurred at a time where there is a high astronomical tide or the full moon time, because the water is pushing above this astronomical tide, that is making the volume of water coming onto the shore to the maximum. And then also, Hurricane Sandy is a bigger storm. I mean, even though Rmax is close to 70 miles, but the storm itself is actually extending to 1,000 miles. Means tropical storm intensity wind speeds were extending up to 1,000 miles from the center of the track. That's why the wider area was able to be affected by this event. And then also the low central pressure and then track perpendicular to the coast, they're all making the storm to be more unique to cause excessive amounts of storm surge onto Long Island and then also into the Manhattan. These are the pictures of some of the observations from our damage reconnaissance survey, particular to Long Island. We were able to get into Long Island, I think 3 days after the actual landfall of the Hurricane Sandy, to do some damage survey. The aerial picture that is on the left-hand side of this slide shows the properties and then also street view of the properties before Hurricane Sandy. The picture on the right-hand side shows the properties after Hurricane Sandy. As you see there, almost like 2 blocks away from the coast was badly affected by Hurricane Sandy storm surge. What we were able to observe is there was about 2 feet of sand deposits up to 0.25 or 1/4 of a mile from the coast, which is really let's say intense in my opinion. And then also there's a lot of damage to the structures in addition to total loss to contents damage. For many of these properties sitting along the coast, there's a total loss to the contents from this event. However, the damage from the wind component of the storm is very minor. Okay, I was talking to the PIA New York president over there, sitting there, thinking that if you look at Hurricane Sandy, damage from wind component is very small compared to the storm surge. However, there are some highly localized areas where we were able to see significant damage to the properties. Okay. Besides that, in general, damage to the property is primarily coming from tree fall. And also, in some highly localized areas, there is a moderate to minor wind damage to the properties. One of the primary reasons for moderate damage to the properties is age of the building. Some of these properties, like the one on the upper right-hand side, actually you can observe that the siding was damaged significantly for that property. The reason is that property is almost like 60 years old. Was built back in 1950. So older properties, we observe significant damage to roof component of a building compared to newer construction, which is a well-known thing. I mean, if we look at Hurricane Ike back in 2008, that made landfall on Texas coast, and also 2004 and 2005 hurricanes from Florida. Historically, older construction performed very badly compared to newer construction. Same thing we observe here. For older construction, damage to roofing is much more significant compared to roofing damage to newer construction. That actually leads into the accurate data for CAD management. How can we manage the different buildings or the data from different buildings for effective catastrophe management? Catastrophe management is not just limited to collecting X amount of premium from the homeowners. We have to understand whether that premium is right or not. Are we collecting right amount of premium for the characteristics that building has or the homeowner has? That's all included in the catastrophe management. In general, insurance companies, they use catastrophe risk models, which are scientific models. They consider different characteristics of the buildings to estimate the loss from a future event or to find the technical premium. Some of the primary characteristics that can impact this technical premium from the catastrophe risk models are occupancy type, construction type, number of stories, and year built. The diagram here on the right hand side actually is a conceptual diagram to show the variability in loss estimates from a catastrophe risk model based on different known unknown characteristics of a building. Here from left to right, that shows the variability in losses depending on occupancy type. In particular, for commercial occupancies, whether it is a restaurant or the gasoline station, maybe a small fish and chip kind of a shop. So they show the variability within the occupancy. For homeowners, it's not a big difference. The graph here that shows within a given occupancy how much a loss can change depending on different characteristics of a building, like construction type, whether it's a wood frame or a masonry. Okay, 1 story or 2 story, built back in 1960 or maybe built in 2011 or 2012. All those characteristics of the buildings can make big difference in the catastrophe risk models to estimate the technical premium. If you don't mind, I want to give you a small test here. I'm not going to ask you any one particular individual. So this is a building actually that I went on to Google Earth and then took this building from which is located in Long Island. Just by looking at this one, we can say this is a 2-story building. Okay. If you model this building in the catastrophe risk model for hurricane technical premium, all we can enter is this is just only residential single family house. I don't know about the number of stories, I don't know about the year built, I don't know about construction type. The model can give you a technical premium of equals to $400 for that property. But there is a variability that is in the order of $157 to $445. Now, we know that this is actually a wood frame building. The technical premium now is $412. There is still a variability around that number, which is from $259 to $445, because other characteristics like height and year built of that property are unknown. Third step, now we know it is a 2-story building. Technical premium from the model is $419. There is still a variability there. The fourth step, yes, actually it was built back in 1960. Now the technical premium is $445 from a catastrophe risk model. So that's how this technical premium is changing. Older the construction, the more the damage. The more the construction is, less of the damage. In addition to this, just by looking at this picture, I can say it has a gable roof. Okay? So gable roofs are more damageable than hip roof because hip roofs are more aerodynamic. That's why they're less damageable compared to the gable roof. Now output it is a gable roof. Now the technical premium went from $445 to $489. So after this, we go back to the homeowner, ask them, okay, it was built back in 1950. Did you replace the roof in the last 10 years? They said that, yeah. My roof was only 4 years old. We replaced it back in 2007. Because of the newer roof, or the roof age is only 4 years, technical premium came down from $489 to $342. So this is how much impact the building details can have on loss results in a catastrophe risk model. Same can be seen on the ground. If you look at the older properties versus newer properties, are the properties that are sitting next to each other. One of its roof was replaced like 4 years back compared to the other one, which is like 15-year-old roof. They can see completely different damage on the ground. Oftentimes, companies think that collecting more data means more expense. But some of the characteristics of the building, mostly related to the roof, are easy to collect. We don't need to spend too much money to collect that data. We can collect some of that information just by visual inspections. Standing outside the property, you can see whether it is a hip roof or a gable roof. You can ask a question to the homeowner. Like roof geometry, roof age, roof covering. They have wood shingles. If they have concrete tiles or the clay tiles, that can also make a big difference. These two graphs here are actually for illustration purposes from catastrophe risk models, how much credit or the penalty that they can give within those models for different roof geometry types. For hip roof catastrophe models, actually they give close to 20% credit. For gable roof, the penalty is in the order of 5 to 15%, depending on whether a gable roof was actually braced or non-braced. They can make a really big difference during hurricanes. Roof age, like I said, older the roof, more damage. The point I want to make here today is, as a community, and then also serving our community, it is on our part to improve the data quality for effective catastrophe risk management. Thank you very much.